rational root theorem. Okay, for this theorem, we need to consider this theorem once we want to find all factors of a certain polynomial. So this will give us the idea on what are the possible roots or solutions of a certain polynomial. And to apply this theorem, you simply need to find the factors of the constant or the n term, divide it with the factors of the leading term. Okay, for example, we have the same, this time we have the given, let's say for example, we have the given polynomial as 2x cubed minus x squared is 8 minus 4 equals 0, the polynomial. And we want to find out what are the possible roots or solutions for these polynomials. To find the possible roots, all you need to do is to find the factors of the constant, which is negative 4, and then divide it with the factors of the first term, numerical coefficient, in this case 2. Okay, so we need to find the factors of 4. This time we disregard first the sign. So first, positive and negative 1, because 1 is a factor of 4. Second, 2. 3 is not, because 3 is not a factor of 4. And then the last one is 4. Okay, where did we get 1, 2, and 4? From the factors of 4. So these are the factors of 4. Divide it by the factors of 2. Of course, 1 is a factor of 2, and then 2 is also a factor of 2. There's no other number which are considered to be factor of 2, only 1 and 2. Okay, next we will now pair or divide the one number in the numerator over one number in the denominator. Let us begin with 1, positive 1 divided by positive 1, 1. And then negative 1 over positive 1, negative 1. Let us pair 2 and 1. So 2 over 1 or 2 and negative 2. Let us also pair 4 and 1. So 4 and negative 4. Let us pair now 1 and 2. 1 over 2. 1 over 2 is 1 half. The negative side of that, negative 1 half. Next, 2 over 2. 2 over 2 is still 1. So we don't need to repeat that because we already listed 1. 4 over 2 is 2, which is already here. So no need to repeat that. Therefore, we have here 1, 2, 3, 4, 5, 6, 7, 8. So these 8 are the possible roots. So these are the possible roots of this polynomial, which are 1, negative 1, 2, negative 2, 4, negative 4, 1 half, negative 1 half. So we just need to focus on these 8 numbers. Nandito lang yung roots ng polynomial. We will choose among these 8 numbers to be considered to be the roots of this polynomial. Yes, sabi ni Cheska, okay lang, nasulat na lang. You can also write positive and negative 1. Okay, but when we reach our next lesson, next week, our lesson next week, you will see that it's important to list down in details. Okay, in details, in order for us to use every number in finding the specific factors. Okay, but if you will ask if it's okay to write them like this, it is also correct. If you want to write positive and negative 1, positive and negative 2, positive and negative 4. Actually, 1 half should be written at first if you want to arrange the factors from the least to the greatest. 1 one half should come first. Positive and negative one half, positive negative one, positive negative two, positive and negative four. Okay? Okay po? Cheska, did I answer your question?
Yes po, thank you.
Let's have another example. Okay. Um, for those who have a problem here in pairing the numbers, so let us discuss example number 2. Example number 2. Same page. Let's see another polynomial. This time we have the polynomial. The polynomial is 3x cubed plus 41x squared plus 121x minus 45 equals 0. Okay. In order to find the possible roots, when say possible roots, ito na yung probable roots. Okay. It will give us several numbers, and among those several numbers, we will just be choosing some numbers to be the factors. And for us to choose those factors, we need to apply synthetic division, which will be discussed next meeting. Okay. At this point, using rational root theorem, we will only find first the possible roots. Later on, from those possible roots, we will find specifically which are the roots of this equation. Now let us find the possible roots of this equation. To find the possible roots, we need to start with the constant, which is 45. We disregard first the sign because we always use positive and negative in pairing them. So the constant divided by the numerical coefficient of the first term. Let us begin with 45. 45 is a composite number. It has many factors. Let us begin always with 1. 1. Positive and negative 1. Okay. 2 is not a factor of 45 because 45 is not divisible by 2. Okay. 3 is a factor of 45 because we can divide 45 by 3. Next is we can get also another number 5 as a factor of 45 because we can divide 45 by 5. Next, 5 times 9 is 45. So 9 is also a factor of 45. At this point, we will now pair 5, 9, 45. Therefore, 15 is also a factor because 3 times 15, 45. And then lastly, we have 45. So these are the factors of 45. 1, 3, 5, 9, 15, 45, including the positive and negative values of these numbers. Divided by 3 is a prime number. It only has two factors, 1 and itself. Okay. Next step, we will now pair numerator and denominator. Let us begin first with 1. So 1 and negative 1. Pair 3 and over 1. So 3, negative 3. Pair 5 over 1. 5, negative 5. Pair 9 and 1. 9, negative 9. Pair 15 and 1. 15, negative 15. Pair 45 and 1. 45, negative 45. Okay, next, we also need to pair 1 and 3. So 1 over 3, negative 1 over 3. 3 over 3 is still 1. So do not repeat 3 over 3 equals 1 because we already listed that. Next, 5 over 3. 5 over 3, negative 5 over 3. Next, 9 over 3 equals 3. Do not repeat also 9 over 3 because you already have 3 and negative 3. 15 divided by 3 equals 5. Do not repeat 15 over 3. Do not write 15 over 3 as a fraction because you can divide that as 5. So do not repeat 15 over 3 or 5 because it is already here. Next is 45 over 3, which is 15. Do not repeat also that possible root because we already have expressed here, 15 and negative 15. Okay, so therefore, these are the possible roots of this particular polynomial. And we can also write in shortcut form. We can start with one third. The smallest among them is one third, followed by 1. So we can simplify the result, the answer as, you can write it this way: positive and negative one third, followed by positive and negative 1, followed by positive and negative 5 over 3, followed by positive and negative 3, positive and negative 5, positive and negative 9, positive and negative 15, positive and negative 45. Okay, so those are the possible roots.